Give me a second. All right. So I think it started. So the other reason, right? The other reason why I kind of got delayed here is because something really interesting happened. I found admin staff on the notice board, that's located on the entrance of the School of Education. And I think I probably spent some, I don't know if it was 5, maybe almost close to, or maybe close to 10 minutes actually, because I was trying to, so we started lecture series number 12 here today, but I was trying to see if I could find the specific date when ICT 1110 is scheduled to take place, as in the final exam. So what typically happens is there usually draft timetables that I churned out. So I don't know if you can see my screen right now, but it turns out that the first draft is out. I'll try and see if, I think I'm going to be on campus tomorrow. I'll try and see if I can identify when exactly ICT 1110 is tentatively scheduled to take place, right? But this is a sign. It's a sign that that very, very soon we're going to be writing the final exam, right? So yeah, normally 1110 is scheduled towards the end, so it's likely going to be somewhere in December, early December or something. But I'll confirm tomorrow, and then I will share the details of the date once this is confirmed. Now, the other reason why I thought it was important for us to talk about this is it turns out that because we have people that are, I guess that are doing different things by way of minors, it turns out that there are usually clashes. So what you want to do, right? What you want to do is to make sure that you don't have some funny course that you're doing that clashes with one of your major courses. It's happened in the past. If you don't identify the clashes that take place, you will be quarantined. Now, I don't know how the quarantining is going to take place this time around, but what usually happens if there's a clash is in the venue itself, you would write the exam, and then I don't know if the exams are going to be online actually, or if they're going to be face-to-face, if you're required to travel to campus. But you would remain in the venue until the exam starts. So you're quarantined to a certain extent, right? You don't want that. You want to make sure that there's no conflict between any of your major courses, EDU 1020, ICT 1110, and your other respective minors. English has always been a bottleneck. The people doing languages, you want to be on the lookout here. Okay, I just thought I just made, this is why I was late actually. It's quite sad, but it was important. I was actually curious to see when the exams for 1110 are going to be scheduled. I thought to talk about that today. But I'm sure if you're part of some funny group, Unzasu group or something, I'm sure they'll be able to share an electronic copy of the timetable. Unzasu has a seat on Senate, right? So they'll usually have access to these things, draft timetables and all these important documents, important things that are discussed. All right, great. But takeaway point, the end is near, right? We are almost wrapping up August, very, very soon. It'll be like 2 months and we're done, right? So if I were you, I'd just keep that at the back of my head, but of course I'm not you. So today, right, we start unless there's any questions regards to the exam and what to look out for, perhaps not, this is draft number 1. So today, right, we start our conversation of lecture series number 12, which is file organization, a bit behind here. We normally have a total of about 21 lectures or something. So we're halfway through, but we're still behind here. So we start our discussion of file organization. Now remember, we are still discussing the high-level functional units of the von Neumann architecture. But we specifically have a dedicated session where we look at file organization and file systems, because it turns out that it's a lot easier for us to understand exactly how secondary storage gets to function. Once we have a firm sense of how data is organized on computer systems, how it's logically organized. Remember that as far as the computer system is concerned, everything, program instructions and data are stored as ones and zeros. But as human beings, it is difficult for us to intuitively figure out what the ones and zeros are all about, right? With a little bit of extra effort here, you'll be able to figure it out, but it's a lot harder. And so what we do, we come up with a logical way of trying to represent those ones and zeros. Files, oh, I have a file, a folder. I open that file, a .mp4 file, could you please send me that photo? It's a JPEG file, right? It's a PNG file. All those things are there to help human beings, you and me, be able to better understand the data that's encoded by the computer system. As far as the computer systems is concerned, there's no such thing as a PNG file and whatnot. It sees ones and zeros, right? And in fact, the way that it's able to determine the composition of those ones and zeros is by making use of program instructions, right? I have an MP4 file and I'm going to use VLC to play it. You're using VLC because the computer is going to make use of the individual instructions that make up VLC to manipulate the data, aka the video that you want to play back at that point in time. So be it the lecture or some meme or something, or one of these crazy viral videos that are constantly popping up online, right? Zambian Watchdog here. So file organization and file systems, very important for us to understand the logical design. And ideally, what we're going to do is just briefly gloss through these things here, right? We will do a bit of revision. Because most of us are already familiar with this whole notion or concept of files and file systems, right? Maybe not, but most of us, anyway, maybe not all of us, but most of us, but want to rub it in. And then we will we'll look at specific things associated with files and in particular file systems. So things like different operations that help us navigate file systems to gain access to the data or the information that we might want. I took some photos 2 years ago and I forgot to share them with the people that I was on the trip with. Where are they? They're on my they're on my external disk. I want to navigate the external disk, right? The external disk is organized in the form of the file system, yeah? File system. Now, the manifestation of the file system is different dependent on the operating system that we're using, but we'll discuss all these things. So we'll look at, is it utility software tools called, is it file managers? And I'll leave it there. I don't know if it's utility or if it's application software called file managers, yeah? The ones that we use to interact with the file system. So I just opened up Dolphin, which is it's a file manager I use on my Kubuntu 18.0.4. And I use it to navigate different locations on my file system, right? So we'll do these things. And then something else we'll talk about here is of course, we will have a very short discussion about file systems, right? Why they're there, and the different variations of file systems that actually exist. And more importantly, we shall continue off our discussion of a particular Unix-like operating system, which we started looking at, that's Ubuntu, right? And we're going to use this as a case study. So we'll look at the Unix file system and understand exactly how files are logically organized on the Unix file system. It turns out it's different when you do a comparison between Unix-like operating system and Windows, right? So pretty interesting discussion, just because most of it is going to be a bit intuitive. By the way, your Android is a Unix-like operating system. We had a discussion about this. So the logical organization of data on your Android phone is similar to what Lighton is looking at right now. Yeah? This thing that Lighton is accessing right now. This is the view you have right now is the same view that you would have if you were to. Let me see if I can connect this. If you were to, I hope it works. If you were to navigate your Android smartphone's file system, right? Wow, I don't know if it's gonna work. Okay, there we go. So if you notice, I'm actually well, it's hot name obviously, but I've just ADB'd into my Android phone, and you notice that if I do a DF here, organization of the file system is pretty much similar to my computer right now. Why? Both Android and Kubuntu are Unix-like operating systems. They're Linux-like operating systems. They're all derived from Unix. Yeah? The differences are just minor. Now I know most of you probably use these fancy file explorers like Midnight Command. I don't know if it's still there or something, or the inbuilt file managers that you have on Android once you install Android. But Nonetheless, we're going to look at the case study of the Unix operating system. Now, this has become second nature now. What we are studying here, the computer system, we know what the definition is. I don't think there will be a question in the exam as to define what is a computer, right? I don't think it's going to happen in ICT 1110, right? But we know the definition of the computer system. We know the high-level units associated with the computer system, what their role, what their various roles are, what they entail, why they're there, right? And in fact, we realize that the different roles or the different components are best viewed by using a pre-existing model, something we're calling a von Neumann architecture, right? So we've got into a stage where we've discussed all these different components, and again, we're still looking at memory. But right now, the type of memory that we want to start discussing is persistent memory, secondary storage, computer storage, right? And if you were to view this from the perspective of the so-called memory hierarchy, we've moved on from the top layer here. We are now discussing this bottom layer. A key trait that differentiates the top layer of this memory hierarchy, this pyramid that represents the memory hierarchy, guys, is the fact that fundamentally power, you don't necessarily need to supply power constantly to the memory component for you to retain the contents of that memory component, right? Right, so ideally secondary storage is there to ensure that the contents, so both program instructions and data, are persistently stored, right, on that particular storage medium. And so another way of looking at it is that it's non-volatile, right? The contents will persist when there's no power being supplied to it. Another difference that's immediately clear when you look at this pyramid structure here is that the relative size of secondary storage, for the most part, is usually huge, right, in comparison to primary memory. Why? Because this is usually used for archival purposes. This is the final destination of program instructions once processing is done, right? So because there's a lot of data that is normally generated and processed, right, depending on what you use a computer for, you typically need significantly more secondary storage capacity than you would things like RAM. Look at Lighton, for instance. Lighton currently has 457 gigabytes, about half a terabyte, I guess, of space, internal storage space. Compare that with the RAM that Lighton's computer has, right? The same can be noticed from Lighton's Android phone, right? You'll notice that it should have slightly more here. It says about it's supposed to be 64 GB anyway, but let's just assume it's 54 GB of space, right? I hope free works here. But Lighton, his phone has 6 GB of RAM, right? So his secondary storage is magnitudes larger when compared to RAM. And in fact, as you traverse closer to the CPU, obviously the behavior in terms of the size or the capacity, there's a decrease, right? CPU cache is going to be smaller, right? RAM is going to be much smaller than secondary storage. CPU cache is going to be smaller than RAM, right? As you go on top of the pyramid structure here. So this casing that we're talking about here, obviously it's for protection, but in most instances, it would also serve as a container that would typically have both the storage medium and the storage device itself, the drive, right? The medium is where data is going to be stored. The drive is the component that actually ensures or facilitates access to the medium itself. And this also includes thumb drives. If you have a thumb drive that you can easily open, a USB stick, but you notice that when you open it up, you find some sort of microchip inside there, a microcontroller of sorts, right? So there's a storage medium in there, and there's a drive as well, which is why it's sometimes called the what? USB drive, right? Some people say, oh, USB disk or something. disk drive, two different things, right? But synonymously, people refer to them, the sort of like assume that you're talking about one and the same thing, two different things here. Again, storage, secondary storage is there for archival purposes, so long-term storage. I have this drive that I've had for almost 1.5 decades now. It's almost 15 years old, and I have stuff that I was saving in the, 2005, 2006 or something, right? It's there, long-term storage. I have this old Yahoo account that I regularly access just because I don't want Yahoo to delete it. I still have access to old emails, right? Old emails that were generated or sent to me many years ago in 2004, something when I was in second year. And all that is possible because they're persistently stored on long-term storage, right? So Yahoo obviously has enough storage capacity to store emails from people, right? Millions of people. The same goes for Google here. But key takeaway point here is that it's long-term storage of program instructions and data. Again, I just want to draw attention to the stored program concept here. Doesn't change the fact that while we are talking about secondary storage or computer storage, the idea behind the stored program concept still holds. This really ingenious idea that both data and instructions are stored in the same location. You install your program, it's going to be right there on secondary storage. You install a portable application, you remember portable apps, right? On a USB stick, it's still going to be on long-term storage, right? So instructions and data are going to be stored there. Right, so we're saying is obviously once you install your program, if you install your program, it's going to be stored on secondary storage. It's going to persist there. And it only moves to different locations once you execute that piece of software. So in the operating system, for instance, is bootstrapped. Initially, it's on disk. After bootstrapping it, portions of it, program instructions will be loaded into RAM, right? So we're saying is secondary storage acts as a storage location for these program instructions. And the rest is history, right? We know the journey that these program instructions will take as the CPU is looping through its fetch, decode, execute, store cycle, right? So from your hard disk or from secondary storage into RAM, from RAM, CPU fetches it, takes it to the registers. During that fetch process, instructions are going to be cached in CPU cache, and then the rest is history, right? Fetch, decode, execute, fetch, decode, execute. It's like fast here. So you immediately notice here then that there are obvious advantages if you are to look at the pros, right, associated with secondary storage when compared with primary storage. So if we were to do a comparison between your hard disk, for instance, and RAM, the immediate benefit can be viewed from the perspective of cost and capacity, right? Cost and capacity. As you traverse down this pyramid, the cost or the component becomes much cheaper, which is why you can get away with having access to half a terabyte of data. I have a disk that is, I think, 5 terabytes. I can buy 5 terabytes of data, right? Because it's relatively cheaper. Capacity as well, because it's cheaper, you tend to have access to more capacity, right? So there's immediate benefits here. The cons here, the disadvantages is obviously speed, and we talked about speed. The other day, somebody asked about what's the disadvantage of I don't know if it was is it secondary storage or throughput, right? Capacity, speed, it's slower. All right. I hope this is making sense. I'm going to pause here to find out if people are following through. Is this making sense?
Dr. Aiton,
yes.
Is there any difference? Is there any difference in terms of latence between the secondary storage and the primary storage?
Well, latency relative to what, though? The obvious answer is yes. there is a difference. Latency is nothing more than the delay, right? So if you're accessing data, let's say you have an external hard drive connected to your computer system and you're accessing data. The latency is the time it's going to take, the round trip, the time it's going to take from the time you initiate access to whatever it is you want from the disk and when you actually gain access to it, right? That's the latency, the delay, right? The time. So the answer is yes, because the components, the speed associated with the components are different. Obviously, the latency is going to be different, right? The question to ask is, if you're looking at this from the perspective of latency, I'm going to throw this back to you, Anita, right? Yeah.
Yes, sir.
Which do you think would have a higher latency? Primary memory or secondary memory? Which has a higher latency?
Secondary memory.
Right. And it can be confusing at times, right? Latency is just a delay. Which one has the highest throughput between secondary storage and primary storage or primary memory?
Primary memory.
Exactly, right? So it turns out that one of them is derived, right? So throughput is derived from latency and measurable, right? It's measurable over time. The latency is just the time, the delay. So if the delay is larger, the throughput is going to be lower, right? Yeah. So there we go. Just answered the question. Good stuff. So this brings us to this whole notion of yes, sir.
Can one of the differences one of the disadvantages of secondary storage, be that compared to primary memory, be that its durability. Sorry. Secondary storage is not that durable compared to primary storage because of the way it is kept. Should I say?
Well, that's a tricky question. That's a bit dicey here because it turns out that here's the thing. Why do you think when we discuss data backup, where do we discuss data backup? I don't know if it's this session or the next session. And I'm really looking forward to data backup, by the way, because we recently lost data, right? Important data. But if you're saying primary storage is more durable than secondary storage, then it's a bit of a misnomer that people will decide to store data on secondary storage, right? We have to be very careful here. We have to be very careful. I guess it depends on the type of it depends on the type of secondary storage technology you're making reference to, right? Like I'll be the first one to tell you that archival formats like tapes, right? Tapes are much more durable, which is why long-term storage of data is usually done on tapes, right? Or at least it's traditionally being done on tapes. So you have to be very careful. I don't know, I'm a bit skeptical about saying maybe the durability part might be used as an advantage here. I don't, maybe not, I don't know. It's a tricky one there. That's interesting to look at, maybe. But it's contextual though. Great stuff. We are thinking, I suppose. Guys, maybe we should, let's look number 15. Maybe we should bring it in the exam, right? Durability and whatnot. I think we should bring it in the exam. Yeah, I don't know. So I guess now would be a good time for us to kind of talk a little bit more about file formats and data encoding, just briefly, because it turns out the dedicated session where we look at data encoding, right? So where we get to understand exactly how these ones and zeros get to be encoded as sound, get to be encoded as video, right? So how is Lighton's voice as he's speaking through the microphone, how is that going to be converted into a series of ones and zeros? We have a dedication session for that, but right now I just want to briefly gloss over this, right? I just wanted to start off by reminding us that these data formats we're talking about are usually the data formats that we consume in videos and text, right? The doc file, I just created an assignment, I converted it to PDF. This is a direct result of the processing that is done by the CPU, right? So once the CPU is done processing that data, it's going to be encoded. Of course, the data becomes information once it's processed, right? Once it's transformed into information. It's going to be encoded into a format that's specific to a use case, a particular use case. So it could be that it's going to be encoded into text, could be that it's being encoded into a video format, for instance, or an image or sound or any other derived format, right? But it turns out, right, that for you to be able to make sense out of the information that is encoded by the CPU, you need to use software. You need to ensure that you're using the correct piece of software. And this makes sense. If you are dumb enough to say, I'm going to open a video file using a text editor, the CPU will allow you to do that, right? So I have this video file here. Oh, I don't want to open 7 GB of data here. I don't want my computer to hang. If I can find a smaller file, goodness. I'm gonna order these by size. Okay, we have a smaller file. So I have an MP4 file. Sure, my computer will let me open this up, right? Go ahead, open it up, stupid, right? But you notice that if I open it up, it'll be gibberish, right? Why? Because it turns out that once the computer encodes data for you, you need to make sure that you use the correct piece of software for you to be able to make sense out of what has been encoded, right? The role of computer system software. And this makes sense, right? Because as you're accessing this data that would have been transformed or processed by the CPU, it turns out that you're going through that loop again, right? You have to use program instructions to make sense out of the data that has been encoded by the CPU. Yeah? So very important, software very important. And again, what we're saying here is that everything, as far as the computer is concerned, everything is represented as ones and zeros. Yeah, so it's binary. In fact, the computer would find it hard to tell apart instructions that a series of ones and zeros could be anything, right? Could be program instructions, could be video, could be an image, right? So this is what the computer sees, but as a human being, you want to be able to actually logically make sense out of these ones and zeros, essentially. Right, and obviously the representation of these ones and zeros is again contextual. If you're dealing with textual content, the ones and zeros would typically, a contiguous stream of ones and zeros will represent the different characters making up that piece of text. If you're dealing with video, then specific segments will represent pixels that will make up that particular image, for instance. If you're dealing with video, which we know is a derivation of images and sound, it's an oh my God. It's a combination of, it's a tongue-tied here, a combination of sound, amalgamation, of sound and images, right? That's what video is. And so the computer will be able to separate, or will be able to distinguish between, just using a codec here, right? Distinguish between portions that make up the sound and portions that make up the images, right? Those images that are being presented to you in rapid succession, the things we're calling videos. Those are not videos. It's not video, it's just an image, right? A series of images being represented to you in rapid succession. That's what video is, right? Right, so what we're saying is usually when you're handling data which is stored on persistent storage, there's typically a broad spectrum of operations that you tend to perform. And the best way of thinking about the different operations that you tend to perform on this data that's stored on persistent storage is from the perspective of why, in the first place, you want to persistently store something. Why? Why do you want to store something for 100 years or for 20 years? Maybe you want to show photos of when you were young to your kids, if you ever decide to have kids, right? 20 years from now, no, not. Maybe 10 years from now or something, when you start having kids or something. I don't know, right? So in that case, you notice that maybe you might want to read stuff that you'd have stored on persistent storage. Maybe what you might want to do is, at some stage, you want to share copies of that data to friends and colleagues, right? Or maybe you want to upload illegal copies of software on some shareware, some weird site or something, right? If you're a bad person. In which case you want to replicate that data, right? So you might want to copy versions of that data, right? Duplicate the data, right? But also, in certain instances, it might just be the case that you're dealing with very sensitive data, in which case you might want to ensure that it's secured, it's properly secured. Banking information that we willingly give away at hospitals. For when you go to the hospital, oh no, well, my blood type is that, I have this disease or something. Oh, it's sensitive information, right? Maybe you have some sort of ailment that you don't want other people to know about, right? Yeah, so we want to make sure that the data is secured, right? So you notice that the type of operations that you tend to perform on data that's persistently stored on secondary storage depends on why you're storing that data in the first place, right? And you notice that there's a generic set of operations that we tend to perform, right, on this data that is being stored long-term or data that is being archived. In certain instances, it might just be a requirement that you archive data, right? Like for instance, I don't know, what am I thinking about here? Maybe your record at UNZA, right? So you're a student right now. UNZA archives everything that's happening, right? So if you're caught cheating and you're reprimanded or something, there'll be a permanent record to say this person was caught cheating, and I don't mean this to be funny, it's actually true, right? So that when you decide, if you're an aspiring politician, it will come out in the open to say this person was cheating or something. They're always caught, by the way, the cheaters, right? But there's this whole notion of retention, right? So UNZA, for instance, will have policies that will state that the retention period for data associated with students should be maybe 100 years or something. Why? Because we know that after 100 years, even though light won't pass through the UNZA, it will be dead. So that information won't, I'll be dead 100 years from now. That information, maybe less actually, that information will not be required per se, right? So what I'm trying to say here is that there are other reasons or other operations that you might have to perform on the data, depending on why that data is being stored in the first place. Right? And you notice that some other operations will come, like backups, for instance. You need to regularly back up data if you want to store it over a long period of time so that you don't lose it. So that in the event that the building where you have servers that are hosting that are housing that data gets burnt to the ground, you have copies of that data backed up somewhere, right? Somewhere, tucked away, somewhere safe. I don't know. I don't know if people remember, but Comesa building was on fire not so long ago, or so long ago now, but was on fire and data was lost, gone, pow, right? Because they didn't think about potential operations they might want to perform on the data. Now, it turns out that these operations we're talking about are really possible because of abstraction. We abstract the gory details of what's going on behind the scenes. So if we are saying we are copying data, or we are deleting data, or we are creating new data, it turns out that we're just, the description of those operations is an abstraction of what's actually happening behind the scenes, right? And really, in terms of files and file systems, or in terms of data that's persistently stored on secondary storage, abstraction helps us to logically represent these things, these ones and zeros, right? We want to be able to logically represent them in this form here, so that when I'm using my file manager, aka Dolphin, here, zoom in, I know that when I look at this icon, right? this icon is, when I look at the icon associated with this file here, the computer, as far as the computer is concerned, these are just ones and zeros. But those ones and zeros are abstracted in such a way that the moment I look at this file, because of the icon, I know this is a PDF file. Oh, it's a PDF file, then I must use Ocular to open it. Or I must configure Ocular as application software that's going to be used by default every time I double click this application. Right? Of course, I could open this using, I guess I can use it using a text editor like Kate, but what good is it going to be, right? It's a binary file, right? Gibberish, right? Is this making sense? I'll pause here to wait to see if this is making sense. Any thoughts about what we're talking about here, logical representation of data? Paul, do you have a question? I see you've activated your microphone.
No, sir.
Oh, okay. Teresa, how do you know the exam is on the 2nd of December? Did you check? Do you have access to the timetable? And Miss Teresa is mute. I don't know what
Yes,
what Austin was saying. Mind, he said. Where did you see it from?
It was posted in WhatsApp groups.
Oh, there we go. It's been posted on WhatsApp group. It's going to be persistently stored, hopefully on Teresa's phone, and whoever got a copy of that, right, it's been duplicated. It is going to be stored on WhatsApp servers for 30 days, after which they purge that information. You'll never find it, right? Make sure you save it. Have you ever seen that on WhatsApp where a photo that was shared with you maybe 2 months ago, you try and download it and then WhatsApp tells you you can't download it or something? Okay, great. So 2nd December, yay. 22 days before Christmas. I think that, I don't know if that means anything, but so anyway, so we use abstraction to logically represent this data, right? And really the logical representation is down to what we've now, I guess it's become second nature, what we constantly refer to as files, right? So data that is persistently stored on secondary storage is normally stored in units called files. Technically speaking, everything that is stored as data on a file system is a file. And I know what you're thinking, well, I don't know what about a folder. A folder is a file. It's a special type of file. It's a container structure, right? File, 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 right? Encoded differently, this is a file. Container structure that has other things, file, file, right? So file do nothing more than just represent the ones and zeros, right? The encoded data. Right? So that data, turns out the stream of ones and zeros are encoded in a certain way depending on the type of data that is encoded on that particular file. Right?
Dr. Ito, I have a question.
Yes, Mr. Sam.
How is it possible that as we are coming from, for example, in data encoding, we're coming from electric signals, and then which are more like representing zeros and ones. How do we come from those electric signals, and the ones and zeros, which are representation of that, to visual effects like the same icon file we were seeing? And then we are saying that this is just an abstract of the ones and zeros. How are we able to see that visual icon? Is it the illuminations that come from the words on the motherboard, and then they, I don't know, maybe they illuminate in such a way that on the screen when they converge, and then on the screen we're able to see this visual icon, and then we say, okay, behind the scenes, simple ones and zeros, which were later, with the help of this software, they were encoded, and then we're able to see what they are actually representing.
Yeah, I mean, so a lot of different things that you just highlighted there, right? So a combination of software and a bit of hardware, right? So what you're calling as illumination, obviously, turns out that your LCD screen is composed of just LEDs, right, that will light up CPU, right? So it's a combination of hardware and software, actually. So the operating system, obviously, with the help of the operating system, the CPU knows that when Lighton, this is a simplistic thing here, when Lighton moves his mouse somewhere here, I should just draw some image, right? That looks like it's an arrow, obviously. I would just draw that image on that particular location so that it visually represents that the position of the mouse, what Lighton thinks is a mouse, is there now. Right? I don't know if this is making sense. Yeah. So, but it's a combination of. I don't know if I'm answering your question here.
Oh yes, I'm trying to picture what you are trying to explain.
Yeah. I don't know. Maybe this will make sense once we jump onto data encoding, which is, I think, immediately after secondary storage, we start looking at data encoding. I think. Hopefully that will make sense. I don't know. But it's it turns out that everything to do with computers, most of the things to do with computers are really linked to patterns, right? Patterns, really, it's just patterns. So it's the best way of trying to visualize or to try and imagine what is going on here is how best you can, because what we're dealing with, what the computer deals with is two things. What you perceive to be a 1 and a 0, right? Or electric signal, non-electric signal, or high voltage and low voltage. And that's that, right? So the best way to think about this is how exactly, what sort of different ways can you represent those 1s and 0s, right? The electric current, how best can you represent those? In terms of like storage of data, it's how can you distinguish a low voltage and a high voltage, for instance? You know, so I don't know. Yeah, maybe once we discuss data encoding, these things will make sense. Let's pause and look at data encoding. And in fact, it will likely make a lot more sense if we, once we start looking at how data is actually engraved on secondary storage mediums like compact discs, for instance, or magnetic tapes, I suppose. I don't know. But right, okay. So again, we're saying, so operations, we're saying programs and data are organized into files. These are the things that you see, right? And if a file is nothing more than just a collection of data, right? Or it's composed of 1s and 0s on disk. It will usually have a name, right? Right, so I have a folder, it has a name. I've created a PDF file that I want to upload it as an assignment. It will have a name, right? A way of trying to refer to it, or to set it apart from the other, from other files on your file system. Granted, the naming of the file is just it's limited to within the confines of a particular directory here, right? So granted, the entity that makes it possible for you to interact, to manipulate these files, to perform all these different operations on files, the thing that makes that possible is the operating system, right? So it has a mechanism that makes it possible for you to be able to interact with files. And I want to draw attention to one of the key functions of the operating system. We mentioned this, it was a bit abstracted, but we highlighted the fact that one of the roles, crucial roles of the operating system is file management, right? Aside from memory management and the other interesting things that we looked at. So we're saying that data is represented as files. It turns out that for the most part, they're technically speaking two broad types of files. So there are what are called regular files and directories or folders, right? And a directory is distinguished from a file because it's a container structure. So you can store other files within a directory, but you can't do that in a regular file. A regular file is typically used to encode data that you might be interested in consuming. So be it a video, or you want to view an image, for instance, or you want to see the results of the marked assignment that you submitted, right? The data would be encoded within a regular file. Now, even though we're saying there are two broad categories, but depending on the type of operating system, you notice that regular files will come in different variations. There are, for instance, shortcuts on Microsoft. Is it Microsoft Windows operating systems has shortcuts, right? So you can create a desktop shortcut that's going to point to some file that exists somewhere on your file system. In Linux, there are things that are called symbolic links, right? So if I have a file that exists here, what I can do is I can create a symbolic link, right, of the file itself, of this file here, right, so that I have access to the file here. I don't know if you can see this. Wow. I don't know if you can see this, but maybe if I it'll be a lot easier if I use terminal that has a somewhat smaller font. You notice there are other files. So regular files have different variations. So for instance, symbolic links, right? And there's ways of trying to figure out what sort of file you're dealing with here, right? You notice that this tells me that this is a symbolic link, for instance. But if I try and run the file utility here on this original file, you notice that it tells me that it's a PDF file. It's a regular file encoded using PDF, right? It's a portable document. It's encoded using portable document format, essentially. Good stuff. So directories, files. So a regular file is nothing more than just a stream of ones and zeros that will represent the content that has been processed by the CPU. And so you can either read the content that already exists in that particular regular file, or you can write to the regular file. So, for instance, you can read a pre-existing Microsoft Word document, or you can modify it and write additional bits, add additional bits to it, right? So that it has slightly more streams of bits than it did before. Can we write to a PDF file? I don't know if I'm still connected.
Yes, I think we can write a PDF files.
Yes, we can, right? Lighton does a couple of interesting things. One of the things he normally does is I don't know if you've noticed that he normally annotates slides as he's interacting with you. I do some of these things for a reason, right? There are certain things that we will never discuss, but my hope is that as I'm showing you some of these utility tools, as I'm showing you the way, my workflow, the way that I use my computer system, maybe you'll be able to pick up certain things. So I noticed a couple of times I'll highlight certain portions of the PDF document, right? What I'm doing here is I'm adding bits to this PDF document. And in fact, if I try to close this file, you notice on top here, there's this asterisk. It shows me that there are changes to this file that haven't yet been saved, right? If I try and close this, it will ask me if I want to save the changes. So I can save the PDF. I mean, it's not as intuitive, I guess, as it's become easier now, but it's not as intuitive as writing to like a Word document or a text file, but you can do that. Okay, can do this, I guess. Ooh, okay. So another way of thinking about this is you should constantly try and think about the way that what you do on a day-to-day basis, right? Maybe not Facebook. Well, Facebook is fine, but at school, right? Assignments or interacting with Moodle, you should think about these things, you know. What role, how is data being persistently stored, right? As you're interacting with Moodle, is there any data that's being persistently stored? How is it being stored? Where is it being stored, right? These are kind of like things that I do encourage you to think about, right? In my is light on persistently storing, I don't remember who, but very nice lady just told us that, I just remembered, Miss Namwila, I think, she just, is it me? So I don't know if it's he or she. Yeah. They just reminded us that the content from the 17th are not accessible on the Moodle. Are they persistently stored on the Moodle? If they are, how, right? I just changed it. It was hidden. I've just unhidden that. I do apologize for that. I forgot to unhide this. How are they being persistently stored, right? Emails. This has now been made available. Ooh, persistent storage, right? I wrote to it and then I wrote beats and I'm writing this. I just undid this. Thank you. It's always nice to be polite. Thank you very much for this. Thank you, Ms. Madam. All right, so good stuff. So you can read the beats. You can write to the file itself, right? So that you modify the beats, you change the beats. So it turns out that in as much as the operating system plays the role of ensuring that, or facilitating file management, but it has little control over the overall structure of the encoded data. The entity that has control over that is a specific application that you're using, right? So for instance, if you are wanting to write or to record video, you must make sure that you're using the correct application. If you're recording music, you do the same thing. If you're writing your assignment, you're using the correct application that is specific to the data that you want the CPU to encode for you. So if you're encoding text, you should by now know the different types of applications that are used to encode text. If you're encoding sound, you should by now know the different types of applications. Some of them are a bit obscure, right? Some of them, I guess, you just download them from the App Store without knowing. Like if you want if you're one of those characters who records other people and they're calling you, right? I want to keep proof or something. Right. So you'd use those funny call record applications or something. Just kind of, I just noticed that I got a notification that this is strange. I hope nobody stopped the recording here. I shouldn't get that up until. Oh, that's a bit strange. I hope it's still recording. Okay. I guess this is still recording. Thank you, Master Makungu, right? For seeing the timetable. It's coming. You want to look at the slots that are going to clash with your other courses. All right, so a directory, like we said, is the file, but it's a special type of file. It's a container structure. So it's used to logically store or organize other files, right? So you can have directories within directories. Pop quiz, how many directories can you have within a directory, right? Is there a limit? Do you think there's a limit as to how many directories you can have within a directory? Or how many nested directories you can have, right? How far down the rabbit hole can we go, right? We can write a script. Any thoughts?
There's no limit, sir.
Sorry? Sorry? I didn't get that.
Site, I don't think there's a limit, sir.
So you soon understand that the file system that you are using will typically have the limit. There are limits, right? So depending on the type of file system that you have, there will typically be a limit. We'll have a discussion. We'll look at some of the popular file systems that are available out there. There are a lot of them, right? So it's not just FAT32 or FAT or something, or maybe NTFS, which is, I guess, the file system of choice on most Windows applications these days, right? Everybody's, oh, I decided to format it using NTFS or something, right? Turns out that they are, I'm trying to, oh my goodness. I was trying to see if we could see some variations of, so these different file formats that you typically have, right, will have different limits associated to them. And you realize that the type, the choice of file system is contextual, right? So it depends on what you're using that file system, for. So do you want data to be rapidly, is that particular storage medium going to be, is it going to be housing data that's going to be regularly accessed, right? Frequently accessed? Or is it just going to be used for archival formats? Are you going to be storing huge or massive swaths of data, large files, like what Lion does sometimes, right? Or is it going to be small little files, right? Turns out that if you're handling massive amounts of files, like if you have gigabytes of files, then you need to make sure that you use the appropriate file system, right? So if you're handling massive amounts of, and this is nothing really, the huge files that are handled, right, elsewhere. There are people that make use of computers for really interesting things, not just watching or liking comments on Facebook. Guys, I just wanted to kind of say, we'll continue this conversation, I guess, next time we meet. Is it tomorrow or something? I don't know.
Friday.
Whenever, or Friday. Yeah, we'll continue this conversation on Friday. Hopefully we finish this, it is Friday, thank you. Hopefully we finish this conversation on Friday, and then we can immediately jump, I don't know if we'll finish. No, maybe we won't. No, we won't, sadly. So we'll continue this conversation on Friday. We want to quickly get to wrap up. We'll look at storage, different types of computer storage, right? We want to make sure that by the time we're done, it's so important, right? What distinguishes Dropbox from these other things we use, right? So I'll just pause for a little while and ask if people have any specific questions, I guess, based on what we just looked at.
Excuse me, sir, I have a question.
Yes, sir.
It's about the computer volatility, about the memory. I was asking, you mentioned that the RAM is volatile. It loses its contents when power is not on. So I was asking, what really happens when you put your computer on sleep? It turns off. Then when you turn it on, you still find your content.
Well, so there's an interesting thing here, right? There's an interesting thing to do with, there's different things that tend to happen. Great question, by the way. There's a thing here. So I don't know what, I'm trying to think. I normally confuse these things. So there's a suspend, there's shut down. So you can hibernate the computer, you can put it to sleep or something, you can shut it down. I don't want to, I'm not sure which one this is. On Windows, do you have hibernate as well? Which do you have on Windows? Besides sleep, what do you have on Windows?
Hibernate sleep. We have hibernate sleep.
Right. So one of these, right? One of these, it could be sleep, I guess. I don't know what happens when I've not used Windows in a very long time, right? So if you put it to sleep, it's likely, what will typically happen is that there's still a little bit of power being supplied to RAM, right? So your sleep would be the equivalent on Linux, if you can see here. If I suspend my computer right now, I'm going to suspend this to RAM, right? So if I suspend it to RAM, there's still going to be a bit of power that's going to be being directed towards RAM, so that RAM does not lose its content. And you do this by using utility tools on your computer to say, when I close the lid of my laptop, I don't want to lose the data in RAM or something. Hibernate, on the other hand, I could be wrong, I don't know which one of these is, but one of these will save the state of what is in RAM onto secondary storage, right? So there's a couple of interesting things. Now, when you're saving the state of what's in RAM onto storage, you realize that there's no point in supplying power, right? So one of them has the obvious advantage of ensuring that you're not consuming any power, right? So what typically happens, and to answer your question, when you put it to sleep, it's not like power is no longer being supplied to RAM, right? There's still a little bit of power being supplied to it so that the data that is in RAM is still going to be available when the person lifts up the lid or switches the machine back on. And you've noticed this, right? One of these, you should try it out, I guess, and report back or something. If you suspend your computer, open up one application, let's say your browser, put it to sleep. If you open it back up, you notice that the time it takes for you to be able to gain access to the content is going to be much faster than when you hibernate, because when you're hibernating, you're persisting that stuff to storage, right? You're dumping it to storage. So switching it back on will mean that you need to retrieve it from secondary storage. It needs to find itself back into RAM. That state needs to be it needs to be reactivated into RAM, and so that takes a bit of time here. So no, right? Well, no, light on. But when I've been in a situation where I'm writing a file and my machine switches off, why is it light on that I can still find contents of that file, right? It's application specific. These days, some applications will save things for you. They have automatic save features, right? So things are being saved for you unknowingly, even when I'm not saving. So I know Kate does this. If only I could find, can I find this? Maybe not. Okay. So what Kate does, right, is there are certain, usually it's fine people, well, no, but why is this like that, right? The people have thought about, they've perfected the art of this, they've thought about interesting things of doing this, right? Let's say 12, I guess, I don't know. Or is it 11? Oh, maybe if I show all of them. I was trying to see if I could find in 12. If I could find there we go. You see this? I don't know if you can see this file here. It's called a swap file. So every time I'm working in this text editor, things are being saved into this swap file. In the event that I suddenly lose power, right? And it happens, right? I don't know if you have one of those funny phones where it just reboots itself, switches off. I was writing my assignment and it didn't save, right? People have thought about that, and some applications will create temporal files for you. So much as that once you switch back the machine or the computer system, you will have access to the data. So in this case, I hopefully do have access to this data here, right? So it's a save point of sorts. Okay, guys, I see it's 1818 here. I'll see you when you see me. Thanks a lot.
One more question.
Yes, sir.
Then what happens when you add a program to your file startup? That does it remain in RAM, or it's also taken to secondary storage the whole time?
No, it doesn't stay in RAM. It's just a startup file is just a way of telling your operating system to say, when you're bootstrapped, when you start up, I want you to automatically start this application. So it's a startup file is just it's a technique that allows you to automate the starting up of the application. So rather than you physically double-clicking the application, the operating system is going to start it up for you automatically. So it has nothing to do. It's not like you're saving that application to RAM per se.
Okay.
Sir,
Oh, and one more thing. Your last download, it's not downloadable. The last screencast you added, sir, still not downloadable on IO subsystem.
He's gone, maybe.
Because, yeah, oh my goodness. This is where I'll have to kill all these up. Oh, there we go. I just freed up some RAM here. It's rough out there, right? When you find yourself, maybe it's a megabyte, I guess. It's rough out there when when you have very little RAM and you're a power user. You have to constantly kill things here. Good stuff. Thanks a lot, and
sir,
good luck preparing
Sir,
for the exam, which is on 2nd December. Sorry.
The last download on IO subsystem is not downloadable.
The last download of what?
Screencast, the last screencast on IO subsystem.
What do you mean it's not downloadable?
It's not even loading. You can't even play it.
Okay. So are you saying this one?
Yes, sir. That's what it's doing.
I don't know about you, but I'm in a part of the world where we've been load shedded today, which is why I'm running out of power here. 19 minutes. Let's do
Sir.
this. Yes, sir.
I have a question.
Okay.
What of these file managers? Would you classify them as utility or application software?
I have no idea. I don't know. That's a good question. What would you class? I don't know. I don't know.
I'm on a stalemate here, otherwise, because there are some that have the option to monitor the system itself, like clearing the cache, clearing RAM, or even clearing residue files that are left by previous applications. And then there are those that are just made specific for just exploring the file system.
So then based on that, what would we? Holy moly! What is this? What would we say then? Wow, this is interesting.
Could it be possible that it's biased to be both?
Oh, it is a utility software too, by the way. Let me see this thing. Okay. Why aren't you doing? Why don't you mark these things? By the way, why? As in the screencasts, right? I don't know what Moodle is doing here. Why is it that you guys have decided not to mark mark the screencast? The different timelines that you have. Is there a reason why? It's for your own good, right? Anyway, maybe you don't want to. I have no idea why this thing is. Oh, maybe it's HTTPS or something. What the hell? What is this? Maybe it's crazy. I don't know which one. The thing is, I'm losing track of this. I don't know which one it is, but maybe a nice way of troubleshooting this would be to. Oh, by the way, we are done. In case you want to, if you want to save data or some crap like that, but we are done. We are done now. I was just trying to see if I could troubleshoot this issue to do with the file that's not loading. Are the others loading though? The other videos, have you been able to play them back?
Yes.
Let's try the previous one. Okay, we're just kind of working, I guess, to try and see what is different. This is a bad example. I don't know if the way I'm embedding these things is messing up. Oh, maybe it's supposed to be HTTPS, right? Probably it's supposed to be HTTPS or something. I don't know. Or maybe I shouldn't use the embed link or something. When are you, have you discussed, when are you writing EDU 1020? How far have you gone with EDU 1020? Have you started looking at, there's some interesting aspects in EDU 1020. Once you start looking at computer networks and the internet, it turns out that there's a connection between data encoding, especially. Can I ask that you switch off the microphone, please? We're playing music. Between data encoding and how data is transmitted onto a network. I don't know if you've gotten to that stage yet, where you get to, so it's I guess it's it's HTTPS. Thanks for that. So have you gotten to a stage where we are discussing the internet, where there's an explanation of how information, when you send a text to your girlfriend or your boyfriend, right? You should be asking yourself, how does that textual content get to be transmitted onto the other side, right? It turns out they're transmitted as ones and zeros, right? It's signals and, or depending on which medium, obviously. And then on the other side, they are reassembled, right? The reason I'm bringing this up is you want to constantly think about what's happening here from the perspective of what is happening in these other courses, especially EDU 1020. I hope you've started doing that, computer networks and the internet. Have you gotten into computer networks and the internet yet?
Not yet.
Not yet.
Oh, okay. Well, I don't know if that's a good thing or a bad thing. Maybe it's a good thing because by the time we're done with data encoding, perhaps you'd got into a stage where you're looking at computer networks and the internet. Very interesting topic. If there's one topic that you want to make sure you attend, it is that topic, because the only other time you get to look at data networks, data communication networks is in 4th year, right? So you want to get it right. Thanks a lot. And for telling me that this thing was not working. It's working now. Bye-bye. Stay safe. Thanks.
Bye, sir.
And good luck studying for the exam on the 2nd.
Thank you, sir.
Guys, I can't put my exam.
Johnny,